this, let's let that load up here. We talked last time about starting with the call to action first, kind of that last sentence, and that really leads to the next type of question that you will see a lot of, which is the which of the following. I mean, I don't have like firm data on this, but just looking at questions, a lot, like 50% are in this format of which of the following. And when you see a which of the following, you are forced to actually look at every answer. Right? You have to look at every single answer, unfortunately, and that really does take some time depending on the problem. All right, but when you're looking at every answer, what you're really doing is you're looking for patterns. You should be asking yourself two questions: what is the same? What is different? And we do this intuitively in some ways. We see things and we're like, okay, this looks the same as this one. This is different than this one. And that helps you when you go back. We talked about this idea of always kind of going back to the beginning, reading the prompt, and then looking for keywords. Okay. So we talked a little bit about this idea that when you have to look at all of the answers, they generally are trending towards the last answer being correct because they want you to go through all of them. So if you were to employ any sort of strategy here, sometimes it's better to go from the bottom up in terms of the answers. Now, does this always work? No, we'll maybe even see that. But a lot of the questions are this which of the following, and you're really looking for patterns. So let's do that here in this question here. I'm going to do this a little bit differently though. Before we look at the question, I want us to just look at the answers and determine what's the same, what's different, kind of just to sort of see if this idea makes sense here. So we don't know what the question is. It is a which of the following. The mean of each data set is 2. The mean of each data set is 4. So two different means. The mean of data set A is less than the mean of data set B. The mean of data set A is greater than the mean of data set B. Based on this, what do you think the question is asking you to do?
Find the mean.
Yeah, in fact, it actually gives you two different data sets. All right. So in this problem here, the question says, which of the following statements correctly compares the means of data set A and data set B? So one thing you could do here is visually kind of inspect the data and decide, because C and D are about being bigger and smaller, is like, does one look bigger or does one look smaller? Can you look at those numbers there? You got 1, 2, 3, 4, 5, 6, 7, and then 2 1s, 2 2s, 2 3s, and a 4. Any idea which one might have the greater mean average or smaller average without doing
Data
it?
set A.
Would you say A has a larger or smaller?
Larger.
Yes, I would agree. So A is larger. So if that's one of the answers down here, A is greater than B, we're probably done. Okay. It's probably not a good idea to calculate the mean unless you have to. So that's why you look at the answers. The answers tell you, they sort of say, okay, go back and do either a comparison or actually do a calculation. And keep in mind, most of these questions are supposed to be done in under a minute. So you really can't be doing very detailed calculations here. All right, so let's look at kind of a more complicated example now. I'm going to do the same thing with you. I'm going to grab the answers first. We're going to look at them, and we're going to try to decide what to even do here. So grab these. All right. Answer A, as R increases at a constant rate, V increases more rapidly if interest is compounded annually rather than daily. If R increases at a constant rate, V increases more rapidly if interest is compounded daily rather than annually. So in the first two answers, the differences in this language down here, compounded annually versus compounded daily. So typically you'll see two answers that are very similar, and those tend to be the ones that you're choosing between. They tend to be, right? All kind of generalizations, some true, some not. The last one here, the third one here, as R increases the constant rate, so it starts out the same, The difference in interest compounded daily and interest compounded annually increases at a constant rate. Okay, so that's kind of related to that. Last one's kind of all over the place here. It says if R equals 15% and interest is compounded annually, a $1,000 investment will be worth $20,000 after 20 years. Okay. Now, again, they tend to be, you tend to want to answer the answers tend to be the ones that are kind of like the same with just that switch there. And that's why I have you do this technique, because when you look at the rest of the problem, I'll do that now, it can be very overwhelming. So this is the full question. And there's a lot of words, you got a graph. But if we know the difference between A and B is in this compounded daily rather than compounded annually, we maybe have a shot. Okay. So notice we go back to the prompt here, and you can even go to the figure. So the figure shows compounded annually, compounded daily. Which looks to be better, daily or annually?
Daily.
Yeah, it's more money. That's usually better in most cases. Which from A or B say that? Which say it's better to be daily than to be compounded annually?
B.
Yep. Notice we didn't read anything else. We didn't read that an initial investment of $1,000 is made at a constant annual rate. And while you may tend to want to do that, we talked about last time, you go right to the last sentence, which of the following in this case, scan your answers now to like know what's going on in there, same or different, and then go back and then find the information you need. It's a very different way of doing test questions than you would see in the classroom. But again, this is what's needed. So let's do another one here together. I'm going to do the same thing again. I'm going to snip in just the answers for us to look at. And this time I want you to look at them and take as much time as you need, 1 or 2 minutes here if needed. I'd like you to tell me something the same, something the different between them, kind of where you're kind of leaning in terms of what you're going to do to answer this question, which I haven't given you the rest of it, but take a look.
The answers B and C are similar.
They're very similar. Yeah. One says greater, one says less than. A is about having the most bus riders on Tuesday. D has the fewest number of riders Saturday and Sunday. Again, the reason we do this is your brain processes this information. I don't really know how this works. I'm not sure anybody does, but it knows to like look for this stuff now. Okay. So I'm going to snip the whole question in and ask you to take a look here at this. All right. Which of the following is true based on these data? Here's your data table. I know you're leaning towards B and C. Decide whether those are it or maybe it's A or D. Let me know what you come up with, please.
Is the answer D?
It is D, yeah. So notice, like, based on the things I was saying, it's like, hey, B and C, there's probably that direction. Not always, right? There's always exceptions, but maybe you're finding that looking at the answers now is a good way to start a problem rather than reading it from top to bottom and then looking at the answers. All right, so let's do this again here. It says, which of the following describes the solution to the equation above, which I'm not giving you? X equals 0, X equals 10 and 1/2. The equation has infinitely many solutions. The equation has no solutions. Okay. So what I see here is that this means it has a solution. And that's where we actually have to solve it. C is well, maybe we're not sure, but infinitely many solutions means that there's some sort of like overlap potentially. And no solutions means that they don't intersect. There's no intersection at all. All right. But like I said, there's always exceptions to everything. This one, you will find that we do have to actually solve here. Let me grab the question fully. Which of the following describes the solutions to the above equation? And this equation looks awful. You might think, well, maybe I'll just try the answer. We'll get to that when to do that. That's not always a good strategy. Definitely wouldn't want to try 10 1/2. That's kind of messy. If you saw an equation like this, how might you start to solve this? What would you do? 4x minus 1/2 x minus 7 equals 7 times 1/2 x minus 7. What kind of jumps out to you as far as solving this?
Solving the right side first.
Do you mean like distributing the 7 to both?
Yeah.
Okay, yeah, and let's do that. So let's go 4x minus 1/2 x minus 7 equals 7/2 x minus 49. Now I see fractions. Whenever I see fractions, I think we need to get rid of fractions. Okay, how can you eliminate fractions in something like this? What would you multiply by to eliminate them?
The reciprocal.
So it is the reciprocal in the case of 1/2, but you're basically looking at the bottom numbers here. Like, let's say it was a 2 and a 3. You'd want to multiply a number that divides into both 2 and 3. So in this case, because it's just a 2, we're just going to multiply everything by 2. But you multiply everything, like the first term, the second term, the third term. Then you do the same thing over here, this one and this one. You have to multiply them all by 2. So that's 8x minus 2 over 2x minus 14 equals 14 over 2x, which is 7x minus 98. All right. So this one here, you got 8x minus 1x minus 14. All right. So this becomes 7x minus 14 equals 7x minus 98. What would you do from here to solve for x?
Subtract 7x.
Yeah. Subtract 7x from both sides. And I'm going to go ahead and add 14 to both sides here. So that leaves you with 0 because there's nothing on the left. 0 equals negative 84. Is this true?
No.
No. So we know it's not A and B because we didn't get like x equals 0 or x equals 10 halves. In fact, there's no x. So now you're down to C and D. And this is one of those things they teach you in the classroom, but maybe you've forgotten in the case of having not done these in a while. Do you remember the difference between infinitely many and no solution when it's in this form?
If it's the same number on both sides, it's infinite.
Yes.
And if it's not equal, then no solution.
That's right. That's right. So notice 2 problems in a row. The correct answer has been D. If you were to guess on which of the following, you would tend to want to guess D because the idea is you're going through all of them and you're putting D here. Now these aren't like computer auto-generated. They're put in a specific order for a reason. So keep that in mind when you're looking at that. Good, really good on that. All right, so let me grab one more here to look at before I have you try a few on your own. All right, so we're gonna do the same thing here. I want you to look at the answers again. Tell me what is the same, what is different about them.
The first 2 start with 2x.
Okay, so what would you say about the slope of the first 2? The slope is the number in front of x.
Oh, it's the same.
Same slope. Slope is the same. You could say its value is 2. Good. Same thing with the next two, right?
Mm-hmm.
All right. What else do you see that's maybe same or different here?
I'm not sure.
All right. What do you notice about the y-intercept? And all of them.
They're the same on both the top and bottom, and then the bottom ones are also the same.
So you got like -3 and -2, +3, +2. Yeah. So they actually, there's actually 4 different y-intercepts. Do you see that? There are 4 different ones.
Mm-hmm.
And the more you practice these problems, the more this will sort of make sense. But if I give you the full question here, and you notice that it is a graph, if they all have 4 different y-intercepts, if you figure out the y-intercept, you figured out the answer. Would you agree with that?
Mm-hmm.
Because they're all different. So keep that in mind here. Go ahead and take a look at this problem and tell me your best answer, please.
Is it C?
Let's see, for that reason alone. Okay. So I'm going to have you start trying a few problems here. And what's hard for you as a student is like, you're going to see the graph, you're going to see the prompt, you're going to see the which of the following. Like if we were in person here, I would take a piece of paper and I would keep covering up for you, because I really want you to try to look at the solutions first. Even if you don't do the whole, like, what's the same, what's different, try to scan the solutions to know what's going on. And that, because that will ultimately save you some time here when you're solving it. So I'm going to give you some questions here. You know, think about taking about 1 minute each time to solve it, but go ahead and take a look at something like this and let me know what you come up with.
Okay. Is the answer D?
It is not D. It is not D. Let's take a look at this two together. Let's just look at the 2x plus 1 times the 4x plus 1. When you FOIL, what happens when you FOIL this? What do you do first? I guess the way I should ask it.
Multiply 2x and 4x and 2x and 1.
Good. So 2x, 8x squared plus 2x plus 4x. And what's the last one that you do?
Multiply 1x. No, 1 and 4x and 1 and 1.
Good, good. Yeah. Now this is where maybe the difference occurred. So this is 8x squared plus 6x plus 1. Okay. Now you do need to bring the 3 down. Like the 3 is part of the answer. Okay. But notice that there are 3 terms in the answer. Which of these has 3 terms?
C.
See, so there's always kind of a way to do these problems without actually doing them. But if you're ever not sure, you can always look for those things too to sort of confirm your answer. Now we got to multiply everything by 3. 24x squared plus 18x plus 3. All right, so FOIL, think of this as practice for the real test. So FOIL is a good thing to remember here. All right, so just to again, to summarize this strategy, we're looking at which of the following type questions. Recommend looking at the answers first. tends to apply to all problems, whether they're story problems or not. But here's another one for you to take a look at. Go ahead and look at this and let me know what you come up with, please.
Is B the answer?
B is the answer, yes. All right, and just notice that the heights are the same in all of these. This is like an extra piece of data, so it increases the mean. You can also use the strategy of same and different when looking at figures, just like we did with that graph earlier, kind of like see which one rises and falls first. Okay, let's look at another problem here. Go ahead and take a look at this. Let me know what you come up with.
Is the answer D?
The answer is D. So a lot of students will tell me things like, well, can I just try the answers? And sure, absolutely. If you're going to try the answers though, you should try them from the bottom to the top, especially on a which of the following. Or you should have a reason for trying that answer. You shouldn't just go A, B, C, D because that's the order they appear in, because that's going to take time away from doing it. In this one, you might also take a look at the square root and think about like, what are the things I can actually take the square root of? Like you can take the square root of 1, the square root of 4, the square root of 9, the square root of 16, and so on. Do any of these numbers actually give you that? And you'll find there's only one that does. So you almost go to the thing that's the most, what's the right word, distinct. This is kind of the most distinct or most difficult part of this. What you would not want to do is square both sides, move terms around, things like that. Not sure if you did any of that, but that would be something to think about. Okay, we're going to switch topics. Hopefully you got a good feel for this, which of the following. It's not really a strategy, it's more of just an awareness of what to do when you see a which of the following, which is you got to look at the answers and look for things that are same or different. Look for keywords in the prompt, or in this case, like the equation there, to like discriminate, eliminate ones. And then if you need to guess D, not C on these types. Do you have any questions or any thoughts before we transition to something else here today?
No.
All right. So we talked a little bit about this earlier, and it's great when I get to work with a student like you that knows things like, if two lines are parallel, that means they have no solution. And you mentioned that's when you get the same number on the left equaling the same number on the right. You also looked at the idea that if they're exactly the same, I'm sorry, this is wrong on the left. You get it's a different number on the right. The infinite solution is when you get like 0 equals 0 or 10 equals 10, something like that. Okay. And then the case that we like the most is when they intersect, right? That's the best case there. But more generally, a solution is an intersection. Okay, so let's say I give you a parabola and a line. How many solutions does this have?
Two.
Two places of intersection. Let's say I give you a circle and a parabola. How many places of intersection does this have?
4.
4. Now think about the case of a line. I know it's awkward, but could two lines intersect like this and then with a third line like that? Is that possible?
No.
Well, okay, it is possible. It's just that you haven't seen this very often. But in terms of the solution, does it change the solution? The fact that 3 lines intersect instead of just 2 lines?
No, it doesn't change.
It does not. That's right. All right, so let's take a look at a new problem now. And you are welcome to use the strategy we've talked about, not use it. Certain problems lend themselves better to another with this. But let's take a look at the following here. A system of 3 equations and their graphs in the XY plane are shown above. How many solutions does the system have? So really, we should start with how many solutions does the system have? What do you say here? I know it's different than what we've looked at, but
4.
4 solutions. Okay, so I think here's what I think you're doing. You're looking at this place of intersection, this place of intersection, this place of intersection, and this place of intersection. Is that correct? Is that he came up with 4?
Yeah.
Okay, and that is reasonable, right? You think, okay, that's where they, but where do all 3 intersect? Is there a place where all 3 intersect? Like right at this first one, do all 3 intersect there at this first
No.
place? How about here?
Yeah.
Okay, how about here?
No.
Okay, and how about up here?
Yeah.
It does. So the answer here, correct answer is 2. Because it has to be where all 3 intersect. And maybe you're just not, you've not seen a problem like this before. I would love to say like, okay, your exam's gonna have problems just like this. Maybe it will, maybe it won't, but hopefully some of these strategies ideas will play into that. All right, is that clear? They got to all intersect?
Yeah, I got it.
Okay, so let me throw this in front of you here. It's very similar to the last one. Let's see if go ahead and look at this and let me know what you think.
It's the answer B.
Yes. Very good. All right, so here's a kind of a similar problem to what we looked at earlier. As hard as it is, I want you just to look at the answers first here. It says, how many different values of X satisfy the equation above? So we know that either none work because they don't intersect, 1 works because they do intersect, or more than 2 because they intersect everywhere. So we actually can eliminate C without doing any work because we know that that's not possible. Either parallel, they intersect, or they're the same line. Right? And we kind of solved one like this earlier. This one's not as bad, no fractions. Why don't you take a look at this one and see what you come up with?
Is the answer A?
You've got no solution. Let's take a look here, just in case you want to look back at this later. So this -3 gets distributed to both. So this becomes 10 minus 3x minus 6. Does that match up with what you have?
Yeah.
Great. So then you can combine 10 and minus 6. So that's 4. Minus 3x plus 4 equals 3x plus 4. Does this resemble what you did, or did you go a different direction when you solve this?
Yeah, that's how I did it.
Okay. So I'm going to subtract 4 from both sides and then add 3x to both sides. So on the left, it's 0. On the right, it's 6x. When you divide by 6, you get x equals 0, and that's okay. X can be 0. What it can't be is 0 equals a number. That's the none. 0 equals a number is none. More than 2 would be like 0 equals a 0, but 1 is the x equals something.
Mhm.
And these are designed to be sort of deceptive, like where, kind of like, well, wait, I got 0. That means something. It's okay if x is 0. Any questions on that?
No.
All right, so let's have you look at another one here. It's very similar. Unfortunately, on the test, you don't get like 2 in a row. They're the same. They're disjointed, but with enough practice, you'll be able to get it. So take a look at this one and let me know what you come up with.
Is the answer D?
Infinitely many. Let's take a look here. So 3x minus 8 equals x plus 2x minus 8. And so 3x minus 8, 3x minus 8. So if it's the same on the left and the right, which is really like what we've been saying, like if you get 0 equals 0, but really it's the same equals the same. So yes, it is. Good. All right, so let's try a slightly more difficult version of this question here. So these are, while you might see 1 or 2 like some of the earlier ones we did, this is your more average question that you would see. It says in the given equation, k is a constant, so k is some number. If the equation has exactly one solution, which of the following could not be the value of k, right? So one strategy here is to actually put these values in for k not x, and then solve it. But that is kind of slow. See if you can do this a different way. See if there's something else that makes sense based on that discussion we've been having.
Is the answer C?
It is, yes. So what you're looking for is what makes the left side look like the right side, because that is infinite. Everything else in this case does give you one solution or something else. But we are looking for one solution. How was that problem and difficulty compared to some of the others we've been doing?
It asked what it could not be.
Yes, and those are a little tougher. Whenever it says the not, those are always tough. Got to think through not only how to solve it, but then the whole not thing. Let's have you try one more here before maybe we transition to another topic. It's nice that we can get through a few topics with you today. How are you doing on this one?
I'm struggling a little bit.
Okay, yeah, always let me know if you get to a minute or two in and you're like, I don't think I can do this, or I'm not sure. Again, whenever it's a cannot or a not, you look for the ones that work. So with one, it's 6W plus 14 equals 1W plus 7. You don't have to solve this. You just have to decide, is the left side the same as the right side, first of all? Are they the same?
No.
Okay, so that's a good starting point here. The next one is when you move the variable, it doesn't cancel. Okay, like we don't need to solve this, but if we did, we get 5W equals minus 7, and that works. Like you don't need the solution, but that works. So you're really looking for two things. Either it's the same or the variable cancels. These are the bad cases. So when you get 6W plus 14 equals 6W plus 7, are these the same? No, but the variable does cancel. And when the variable cancels, that's not good. You see that?
Mm-hmm.
Okay. Can you keep going here? So we got 6W plus 14 equals 7W plus 7. If we move the 6W to the right and the 7 left, you get 7 equals W. That's okay. 6W plus 14 equals 14W plus 7. If you move the 6W right and the 7 left, you end up getting 8. You get 7 equals 8W, and that's okay too. It's a solution. So do you see how 3 of these give you a solution, but B does not?
Yeah.
And that's, and really what you're looking for is the same versus what's different. All right, so just to kind of illustrate this point a little bit more here, I've got a new question, but rather than look at the full question, I want you to look at A, B, C, and D, and I want you to solve each of them. Solve each of them for Y. And let's just start with A. So go ahead and solve A for Y and tell me what happens. Do you get a number? Do you get no solution? Do you get infinite solution?
Just for A.
Yeah, just give me that one and then we'll go to B.
I got 2y equals 5.
Okay, so what does Y become? Like 5 over 2, divide by 2?
2.5.
Yeah, but you get a number, right?
Mm-hmm.
Good. All right, so do the same for B and let me know if you get a number or not, or something else.
I need help on that one.
Okay, so we're going to subtract Y from both sides. Tell me what the left becomes.
Negative y.
Left side.
Or
Left
left.
side. Yeah. Y
0.
minus Y is 0. So this is what I was hoping you would see. You would see that, oh, this is a problem. This means no solution. Okay, so try the same thing for C.
That's also no solution.
That's right. And the last one here, when you subtract Y from both sides, oops, sorry, subtract Y from both sides, not 5. Subtract Y, you end up getting 5 equals 5. What does that tell you?
Infinite.
Infinite solutions, good. Okay, so now let me give you the full question, and I'll just snip that into the top here. Because I really could ask any of these things, but which of the following has exactly one solution?
A.
A. Good. All right, so maybe try one more here. If we do another lesson, I'll definitely have another test taking strategy to talk about, and we'll pick another content area to go through. So take a look at this. Let me know what you come up with. Let me know if you have any questions.
Is the answer D?
Yes. Very good. All right. So we've kind of done this one, but we'll do it anyway. All right, let me make this a little bit larger. It's not easy to see.
Is the answer A?
Yes, good. All right, so here's another question for, look at this one together at least a little bit here. The graphs in the XY plane of the two equations above have how many points of intersection? What is the graph of the top one? What does that look like? Or what's a word you could use to describe that?
I'm not sure.
So parabola or U-shape.
Oh, okay.
Okay. And how would you describe the second one?
A straight line.
Some sort of a line. So just to be clear, the reason it's a parabola is that square there. So
Uh-huh.
here's some possibilities for the line. It could miss it. It could hit it once, or it could hit it twice. See how 3 is an impossibility? There's
Yeah.
no way a line can hit it 3 times. Okay. So sometimes you can just eliminate an answer, and guessing with 3, while we don't want you to guess, it's better than guessing with none. You could graph this if this were in the graphing section, or calculation section. I don't think that you've got that option though. So you would have to use some sort of a substitution technique for this. All right. So notice there are many questions where you don't actually have to solve. You just have to know what to look for to determine which answer is correct. So keep that in mind here. It's not really as much about solving as it is, say, in the classroom where you're asked to solve and get a final answer.